Hi and welcome to the Maths GCSE Prediction 2 for the Edexcel Higher paper. So you've all done paper 1, and what I've done is I've looked at the most likely topics to come up for the paper 2 and created a paper from them and taken off all of the topics that have come up already in paper 1. Now, like before, all of these questions are available on the site. For reference, the questions on the site, the numbers do change. So your answers on the site might not be the same as the answers you'll see in this video. I will make a PDF for this video, which probably the link to it's coming up now, and the link to it's in the description. So if you want to print it out and have a go at it on paper, then please feel free. As I mentioned, the site has this paper online. So if you want to go in and have a go at it yourself, it marks it like I'm going to show you here as you go along, tells you what grade you're on at any given question, and you can log in and save your scores. Now, looking back at paper 1, one of the problems was an awful lot of people were using the server. So what I've done in the last week or so is try to set up a second site in case the first site has heavy traffic. I've done that now. The link to it will be in the description when it is absolutely finalised. The second site that I've set up is an overflow site. You can't log in on it, but you have access to all of the papers. The servers are quite expensive for that second site, so if you can try and use the first one and log in, and normally the first one should be fine. But if you find that you go to the On Maths site and you can't get through, then just look in the description here and there'll be a link to the new and improved and faster site. So what I've done is I've bought a whole server, dedicated server, but it is very, very expensive. So if you can use the onmaths.com site, that would be appreciated. So after all of that, let's begin. So, question 1 is now up on the screen. If you'd like to pause the video now and have a go. Okay, so unusually, maybe, averages didn't come up at all on paper 1. So this is a simple-ish averages question. It says each card has 0 and a number between 0 and 9. Now that's quite important to remember that. The range of the cards is 6. So if the range is 6, that means the distance between the highest and lowest is 6. Now looking at this, the highest is 9. And the lowest at the moment is 4, which would give you a difference of 5. And it says the range has to be 6. Well, the only number there that will make the range 6 is 3. Now some people might be thinking, well, okay, can't we just add 6 to 4 and put a 10 in there? You could if the numbers weren't 0 to 9. So if you wrote 10 in there, that won't be worth a mark because the question says they have to be between 0 and 9. Right, on the second one, the median's 5. Now the median means middle. So if I write these in order of size, 4, 5, 6, 7... the middle one has to be 5, so this has to be in the middle. Okay, so looking at that, there's 2 to the right of it, so there needs to be 2 to the left of it. So you could have 0, 1, 2, 3, you could have another 4, and in fact you could have another 5, because that would still leave that 5 there. So it's just any number between 0 and 5. So you could have had 1, 2, 3 or 4 as well, and that would be worth 2 marks. Okay, so nice easy one to begin with. Let's go on to question 2. So, if you'd like to pause the video now and have a go. Okay, so nice scatter graph. I was a little bit surprised scatter graphs didn't come up on the first paper, but this is the downsides of predictions, is that you don't 100% know what's going to come up. So it says describe the relationship, and another student got, alright, so it's an estimating and describing question. Now whenever I see a scatter graph, whether I'm asked to or not, I'll always do a line of best fit. line of best fit is roughly the same amount of points above it and below it, but don't bother counting, okay, because they're quite lenient when you use line of best fits. And it's a line that goes with the data. Now, some people think it has to start at 0. It doesn't have to start at 0. Okay, there's plenty of scatter graphs. In fact, almost all scatter graphs don't start at 0. Okay, so you just put a line going straight through, roughly with the data. Now it says describe the relationships. Now this question you've got to be careful of because of the wording of the question. The type of relationship is negative, okay, because it's going down. Now sometimes when you're describing a relationship, it would be as maths results go up, history results go down. So you've got to be careful about the phrasing of the question with that one. Now the second one, it says another student got 26 on their history test. Okay, so straight away I'm thinking, right, let's draw a line across from 26 over 1, 2, 3, 4, 5, 6. You're going to have to forgive me because I'm not going to be totally precise. Okay, because it's quite a thick pen. And then we go cross and down to the line of best fit. And we've got 1, 2, 3, 34 I've got, but you might have slightly different. Now, what I recommend here is as long as you show the working out on the scatter graph, they're very lenient on this. Now, if I'd written 24, then they wouldn't be that lenient. But as long as you can show them and physically show them on the scatter graph how you got your number, then that you will always get the mark. Okay, so I estimate that they got 34 on their maths test. Fantastic. Okay, so we're almost at an E already, and we've only done 2 questions. You'll find that on the higher paper. So, question 3, if you'd like to pause the video now and have a go. Okay, so for the online version of this, which I've taken these questions from, I've had to be a little bit more specific than maybe they would be in the exam. I've been very specific over what I want as an answer, but they might leave it quite open and you could have your answer in pounds or dollars in the actual exam. So we've got a laptop in the USA which is in dollars, and we've got a laptop in the UK which is in pounds. So clearly I've got to convert one of those so that I can compare it, because I'm looking at which is the cheapest. But on this question it's how much cheaper is it in the USA than the UK. Now, given the fact that the answer is going to be in pounds, I'm going to convert the dollars into pounds. Okay. Now the conversion rate it gives us is £1 equals, that comes up, $1.43. Okay, we've got $2,760 that we want to convert. Okay, we want to see how much that is in pounds. Now with this, to get from dollars to pounds, well, to get from pounds to dollars, I times by 1.43. But to go the other way, I'm going to divide, oh that's dodgy, by 1.43. Okay. Now just try it on your calculator, 1.43 divided by 1.43, and you will get the answer of 1. So I'm just going to do the same with this. Okay, I'm going to divide this by 1.43. Okay, so I get my calculator out because it is a calculator exam. 2760 divided by 1.43. And it gives me the answer of £1,930, and I'm going to round this 7 pence. Okay. Now the question says how much cheaper is it than the UK? So the last step is to say, well, the UK is that amount, and I'm going to take away what it is in the USA, which is the amount we've just calculated. Okay, so I'm going to write 2300 take away 1930.07. And you might get a fraction come up on your calculator. Just press the S to T button, which is the one just above the delete button, on the Casio calculators, and you have £369.93. Now be careful that you set your working out properly with this, because sometimes they have a little star next to these types of question, which means they're looking for how you set your work out. Now I've set my work out pretty well, okay, but what you might want to do is write actual written descriptions in about what you're doing. So say that this is the price of the USA laptop in pounds, and so the difference is, and it doesn't hurt just to write a few words, because when they look at, if you get the answer slightly wrong, it makes it a lot easier for them to give you maybe 2 or 1 out of 3 marks. And even if you get the answer right, if you have to show working out to get the marks, then it makes it a lot easier for them to give them to you. Okay, so if you've got that right, you're already on an E. So let's see if we can go higher. Question 4, if you'd like to pause the video now and have a go. Okay, so one of the modern wonders of the new calculators is they have a lovely fraction button. Now in the Casio ones, it's the third one, so if you go to the shift, which is the top left one, it's 2 below that. It's 2 rectangles, one on top of the other with a line on it. It looks like a fraction. And if you press it, it gives you a fraction straight away. For this one I want to press the square root button, then 86.07. Then I want to press down on the cursor, and 108.4 take away 85.3, and I will just press equals, and it works it all out. Now sometimes you might get a horrible fraction, and again if you get that you press S to D. So I'm going to write out exactly what it says. So it says 0.4016186959. Let's try and tidy this up. Okay, now in the mark schemes, actually you only have to go to about maybe 5-6 decimal places, but it doesn't hurt to write the whole thing down. Now it says round it to 4 decimal places. Now 4 decimal places, if I change my thing, is I'm going to include this one, this one, this one, and this one. Now we look at this one, if it's 5 or more, that 6 will go to a 7. If it's less than 5, that will just stay as a 6. Now because that's a 1, that's less than 5, so that will just stay the same. 0.4016. Now sometimes they'll say significant figures. Significant figures are the same as decimal places, but you don't start counting at the decimal point. With this one, actually, significant figures would have been exactly the same, because we don't count zeros, so 1, 2, 3, 4, it would have been the same. Okay. Now, if you want help with how to use a calculator, or you're not quite sure how to use a fraction button, I'm looking at doing a video on that soon. So have a look at the YouTube channel and see if I've made that video yet. Okay, let's move on. So, question 5, if you'd like to pause the video now and have a go. Okay, so on paper 1 they've sort of avoided questions like this, so I imagine there will be an algebra and shape question somewhere in the second paper. With this one it says the perimeter is a number, and we can also work it out as algebra. Okay, and you'll find that for these types of questions you'll want to do this. You'll want to work out an algebra, work it out as a number, and then just put them equal to each other. So I'm going to draw a line down, and I'm going to say on this side I want the algebra, if my thing doesn't go weird, and this I want the number. This pen's going a bit weird, right? Okay. The algebra for the perimeter is just the distance around the outside, which is going to be 5x plus 4. So I'm going to start over here somewhere. So 5x plus 4. Then add this one, so plus x minus 4. then add the bottom one, so plus 5x. The number it's given to us in the question, 154. And because they're describing the same thing, I can put them equal to each other. Okay. Now I collect the like terms, 5x, 6x, plus another 5x is 11x. Then 4, take away 4, well that's nothing. Okay, so actually that's quite a nice easy question. Equals 154. I want 1x, so I want to divide both sides by 11. So we have x equals, now I might not have to use a calculator for this, but I'm going to anyway, 154 divided by 11 and 14. That's probably, you should know, maybe, if you've done your 11 times table to 15. Right, okay. Now, it doesn't, now some people would go, right, 14, done. Okay, but that's not what the question asks. The question asks for the area of the triangle. So to work out area, we need the base, which is this one, and the height, which is this one. Now you might say, well, what about this one? The height and the base, which is how we work out area of a triangle, have to hit each other at right angles. So the only two that hit each other at right angles are these two. Now actually you could call this the base and this the height, it doesn't matter because we're going to times them together, so it doesn't matter which way around we do it. So the formula for the area of a triangle is half times the base times the height. So it's going to be half times, now the base is 5 lots of x. So on my calculator, 5 times 14, 70. The height is going to be x minus 4, so 14 take away 4, which is 10. And I already know the answer because 7 times 10 is 700, and then half of 700 is 350. But I'm going to type it into my calculator to check. So 0.5 times 70 times 10, or 70 times 10 divided by 2, whatever you do, you'll get the same answer, 350. Now you might think, well, why haven't you put centimetres squared? It's an area. Well, because it's asking for the value of A, and it's already saying that A is centimetres squared. But you will never lose a mark for writing centimetres squared, so it's probably best you do. Okay, let's move on. Question 6, if you'd like to pause the video now, have a go. Okay, so you might think, well, transformations already come up on paper 1. Well, you're right, transformations did, but there's two differences. First of all, it was doing them rather than describing them, and secondly, they weren't on what this one is on. Okay, the other one that didn't turn up, obviously, was enlargement. I think there is a chance of enlargement coming up. It was basically a choice between this one and enlargement. So I would recommend that you revise both. Now obviously this is a translation because the shape has stayed the same, exactly the same, all that's changed is its position. So first mark is for translation. Ooh, that was dodgy. I think next time I get some money I will buy a nice new tablet for this. Okay. So translation, and then we just need the amount of up and down and left and right. Okay, so it doesn't really matter marks wise which way around you put them if you put them as words. So for me it's probably easier going left first. So it's one left, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 down. Okay, and that's good enough to get both marks. You might want to put up and down first and put left second. It doesn't matter as long as you put it in words. If you put it in vector format, then it does. Also, if you put it in vector format, which if you don't know what that is, just look it up, no problem, or message me, I'll have to go through it with you. In vectors, it's right and up. So if you're going left, then it's -1. If you're going with 9 down, then it's -9 if they ask on that question. Okay, so we're already at mid-D if you've got all of them right so far. So, question 7, if you'd like to pause the video now and have a go. Okay, this used to be known as an Edexcel staple for higher trial and improvement. This is actually the last year that they can ask you trial and improvement. So a lot of people have theorised that this is going to definitely turn up. There are some people who think it's not. I have no idea. We all thought it was going to come up a few years ago and it didn't. So I think it's more likely to come up than not. So it's definitely worth revising because it's quite easy marks as long as you know what you're doing. So it says that there's a sum there and they've got an answer and they know the solution is between 4 and 5. Now don't ever try and solve this not using trial and improvement. The question will normally say use trial and improvement, okay? Because there isn't a GCSE topic for how to solve these. That moves on to A-level with cubics. So it has a solution between 4 and 5. Okay, so we want to try and get that solution. So first thing I'm going to try, well, what's sensible to try? Probably 4.5. Let's just always start in the middle. So I'm going to say I'm going to try 4.5 and I can write the working out. I'll write the working out for the first one and then I'm not going to bore you with just sitting there writing working out because you can see what's going to happen. And I can get my calculator, 4.5, and then I press the X with a little square on it, 3 minus 4.5 squared. Now, as I said before, if you're having problems typing this into your calculator, I will do a calculator helper topic. So that's too low, okay, because 70.8 is too low. Now, I don't think 4.6 could be much better, so I'm going to skip to 4.8 I think, and I'll probably skipped way too much, but we'll see. So I'm going to type in 4.8 cubed minus 4.8 squared. Just type it into my calculator. Okay, so I get then 87.552. Okay, which is too low still. Okay, but I've got a good feeling about 4.9. I think 4.9 will be too high. Let's try that. So 4.9 cubed minus 4.9 squared. And that is, so 93.639. And that's too high. Okay. So I've managed to trap the real answer between 4.8 and 4.9. And because it wants the answer to one decimal place, my answer will either be 4.8 or 4.9. Okay, it's going to be one of those two. But I don't know which one of those it's going to be. Now if I just explain this, I draw a line here. We've got 4.8 here. Okay, if I can draw it. And 4.9 here. Okay. And the number is somewhere along this line. Now, if I draw a line down the middle, if it's this side of that line in the middle, then it will round to 4.8. So I'd write 4.8. If it's this side of the line, it will round to 4.9. What point is that line at? Well, it's at 4.85. Okay, the answer's not going to be 4.85, but we're going to use 4.85 to see what it's going to round to. So the last thing you've got to do is do 4.85, or a middle value between these two. Okay, so I'm going to type it in now. 4.85 cubed minus 4.85 squared. And I get 90.561625, to be precise. Okay, and that's too low, just slightly too low. Now if that's too low, it means our value is probably around there somewhere maybe. Okay, because this one is only just too low. That means it will round to 4.9. Okay, it will definitely round to 4.9. So our x value is 4.9. Now some teachers, naming no names, will just say, oh well, look at these and then look at which one's closest. Okay, that doesn't work because this is a curve. If you looked at the graph, it would be a curve. It doesn't work that way. It's not a straight line. So it can be deceiving. In the mark scheme, it wants this value here. It wants it. Okay, so write it down. It takes 2 seconds, but it guarantees you get all 4 marks. Okay, all right, let's move on. Question 8, if you want to pause the video now and have a go. Okay, so on paper 1 there weren't too many angle questions. There was a circle theorem question, but there weren't too many angle ones. So with this question, there's a few rules you need to remember for it. And in the actual exam, try and make sure you write down how you got all your answers. So first of all, this one here, this one and this one are interior angles. Okay, so I could write that down, interior. Okay, interior angles add up to 180. So this one here and this one here add up to 180. So I'm going to do 180 minus 130. Okay, I shouldn't need to, but I'm going to use my calculator because stress of the exam might make me not realise simple mathematics. And I can see that's 50 degrees. Okay. Be careful with the degrees, not making it look like 500. This one here, so right, angles on straight line. Okay, these two add up to 180 because they're on a straight line. So 180 minus 130. And both of these get you 50. Okay, so this one here is 50. Okay, this one here has to also be 50 degrees. I should put degrees on both of them because they're bottom angles in an isosceles. Okay, and then this one here will be, so it'll be angles in a triangle. Angles in triangle. So it would be 180 take away 50 plus 50. So we're taking the two lots of 50 away from 180. And again, you shouldn't have to use your calculator, but if you want to, that's fine. So that makes 80. So that's 80 degrees. And then this is angles on a straight line. So angles on a straight line. So angles on straight line. This pen is rubbish. Okay. Oh, right. So it's going to be 180. Take away the angles we already know, so 50 and 80. Okay, and use your calculator, feel free. So obviously 50 plus 80 is 130, and then 180 take away that is going to be 50. Now some of you might notice that actually this, I'll show you, I'll just put this in first. This whole thing here is symmetrical down this point here. Okay, so if that's 50, that's going to be 50. It's just completely symmetrical. Okay, so we finished that question eventually. Let's move on to question 9. So if you'd like to pause the video now and have a go. Okay, so a good old stem and leaf diagram. Okay, these numbers here are the tens. To show the person looking at it that these are tens, I'll just write random numbers. Okay, I picked the lowest that's going to be in the stem and leaf, and I'm going to say that means 32. The other option is that could mean 3.2, and these could all be decimals. Okay, so that's why we do the key. Okay, so I'm just going to try and do these from highest to lowest as I go along. So I don't need to write 32 because the 30 is already there. And let's cross them out as I do it. So I'm going to put 2 there. Right, what's next? 41 I think is the smallest of the 40s. 43 I think is next. 44 is next. Is there another 40? No. 48, there we go. And then 50 is the smallest. 53, 59, 64. Now you might be thinking, well, what are the 3 marks for? Surely that's only worth 2, one for the key and one for the stem and leaf diagram. Well, you get 1 for drawing a stem and leaf diagram properly, and then you get a second one for ordering them. They have to be in order of size. Now if you want to do it twice, that is absolutely fine. They absolutely allow that. But if they've drawn one out for you, then if you're going to do it a first time without it being in order, just do it somewhere else and then do the proper one where they've drawn it out for you. And just don't forget the key, because sometimes they don't ask you explicitly to do the key, but make sure you do it. Okay, we're already on a C grade if you've got 100% so far, so let's keep this going. Question 10, if you'd like to pause the video now and have a go. Okay, so to probably quite a lot of you, this is second nature. If it's not, then listen carefully. With sequences, when you're finding the nth term, find out what they're going up in. So that's going up in 7, and that's also 7, and that's also 7, which is good. Now always check that a few of them go up in the same amount. What you might have is a quadratic sequence, but this is an arithmetic one, so you should be fine. And so the 7 goes before the n, so it's 7n. Now if 7n is just the 7 times table, if you look at this, this is not the 7 times table. Okay, so we need to add or subtract something else here. Now there's a couple of ways of doing this. The easiest is you just go backwards 1. Now to go backwards instead of forwards, we're going to take away 7. So it goes 8, 1, and then what will come next. So 1 take away 7, thinking about my number line, would be minus 6. And whatever this value here is, the 0th value, you just literally put it at the end there. How easy is that? So that's the nth term. Okay, try and get confident with that, because sequences didn't come up on the first paper, so there's a good chance you'll be asked a question on them. Now I've changed this question to slightly to make it more easy to do on the website. Normally it would just say, is this a term in the sequence? I've said, well, show that it's not by writing the term directly lower than it. If you show the term lower than it and the term higher than it, then you can show it's not in the sequence. Okay, because those two are, and so they can't have a middle one in the sequence as well. Okay, so wow, so 574. Now, one way of doing this, if we weren't answering this type of question, if the nth term is this, then we're going to pretend that that does give this answer, 574. Okay, and we're finding out what term in the sequence, okay, whether it's the 5th term, 6th term, whatever. Then I'm going to add 6 both sides. I'm going to put my lines down in a second. Let's put some lines down. I like lines, they just structure it, make it look nice. Okay, so if I add 6, then I get 7n equals 580. And then if I divide 7 both sides, then I'm do it under here, n equals, now let's type it into the calculator, 580 divided by 7, and I get the answer of 82.85 blah blah blah. Now, oddly enough, I have already proven that it's not in the sequence, because this would have to be an integer and it's not an integer. Okay, so it can't be the 82nd or the 83rd. It's slightly higher than the 82nd, or in fact slightly lower than the 83rd value. Now, because the question says write the term directly lower than it, the one directly lower than it would be the 82nd. So I'm just going to do 7 times 82 and then take away 6. I've just put 82 into the nth term. So I use my calculator. 7 times 82 equals, take away 6, and it is 568. So 568 is a term in the sequence, and then 7 higher than that would be. So the answer to my question is this. Okay, so to do this type of question, get the nth term and get it equal to the number that you're testing. If you solve that and you get an integer, then it is a number in the sequence. If this is quite a low number, you could just carry on this sequence. Okay, but if you have a look at it, you would have had to do that 82 times before you got to the right answer, which is not necessarily a good use of your time. You could have skipped a few, you could have done other strategies, and if you've got any, please let me know. I know quite a few ways of doing that, but I think this is the most clear. So let's move on to question 11, and I'm going to put both parts of this question up. I know it's a bit small. Okay, so if it is too small, then you can just go back and have a look at the larger version. If you'd like to pause the video now and have a go. Okay, this bit here you won't be asked necessarily. This bit here on the website, you type in the numbers here and the graph comes up. But because this we're not doing this on the website at the moment, I'm going to show the answer actually on this graph, although I'll probably get it slightly wrong, who knows. The accuracy wise, it's quite a small graph. So, frequency polygons. Now, frequency polygons are marked at the midpoints. Okay, they're marked at the midpoints. So that's 10, 30, 50, 70, and 90. That's where you will mark them. So 10 is 0. 10 is 0. 30 is 21, and I'm going to be as accurate as I can. 50 is 53. So that's roughly there. 70 is 27. So that's about there, roughly. And 90 is 8. It'll be down there somewhere. Okay. Now that's worth a mark so far, because I've plotted them all on at the midpoints. The last mark for this is joining them up. So I'm going to get my ruler and I'm going to just literally join them up. Now, the temptation for some people is to join this one and this one up because they think, oh, it's a polygon. That's what polygons look like. Don't. Only join them up going from left to right like I've done there, and you'll get full marks. And that at the moment is worth full marks. Okay. Now let's have a look at this one. So it says, come and sell over a quarter of our stores, get over 60 customers. Are they correct to say this? Okay, so where is 60? So let's have a look at where 60 is. So this one is above 60 there, and this one here is above 60. Okay, that's where 60 is, 60 and then to 80 and then 80 to 100. So altogether we've got 27 and 8. So I'll use a calculator, why not, it's there. 35, that's a shock. So 35, so over 60 equals 35. And does it say in the question how many there are altogether? No, it doesn't, so we're going to have to work that out. So we're going to add 53, add 21, that's 109. So total equals, what did I say, 109. Okay, so let's have a look. So proportion over 60 equals, and that's going to be the amount over 60, which is 35, over the total amount, which is 100, and I think it was 9. That looks a bit dodgy there. Let's sort that out. Now it says that we want it as a decimal place. Okay, so I'm going to type in 35 divided by 109. Okay, fraction over just means divided. Now if you get a fraction in your calculator, press the S to D button, and we've got 0.32 to 2 decimal places. I'm going to say 2dp, everyone knows what that means. Okay, so are they correct to say this? Over a quarter of our stores get over 60 customers. Well, 0.32 is above 0.25. And I'd probably say that 0.32 is greater than 0.25. And I'd write it in words as well, saying, therefore, yes, they are correct to say this. It says in my question, just show the correct percentage as a proportion. And I should have done to 3 decimal places, so let's just change that to 3 decimal places. So it's 0.321. But the actual exam will want a written final bit here saying 0.32 is above 0.25, so therefore yes, they are correct to say this. You might say, well, why have I put 0.25? Well, a quarter is 0.25, so they're saying over a quarter. 0.32 is over 0.25. Oh, there we go. Quite a heavy question, so let's hope the next one's slightly easier. So if you'd like to pause the video now and have a go. Okay, there are 3 main ways of doing this type of question. The problem is, some people look at that and go, well, surely this one is the best one because it's the cheapest. Okay, and this is what this question's about, and best value probably will come up on paper 2, so it's one worth revising. Now, some of you are screaming at home, no, that's not the better value, because you get less. So you've got to understand which of these is the better value, given the fact that of course this one's going to be more expensive because you're getting more. 3 ways of doing it. Either you work out how much of a tissue you get per penny, and obviously the biggest one would be the best, or you get each of these so they're the same amount of tissues, or the method we're going to do is work out the cost per one tissue of each of these. Okay, that's what we're going to do because it seems to make the most sense. So I'm going to show the examiner I'm looking at the 24 pack. Now, what I want to do is I want the total amount of money, which I'm going to convert into pence because it's going to be easier, and I'm going to divide it by 24. So I work out what one tissue is worth. Get my calculator, 662 divided by 24, and I get 27.58 blah blah blah. Okay, then I look at my 20 tissues, I do exactly the same thing. This time it's 478 pence. I'm going to divide it by 20 because I want the price per one tissue. Okay, and I probably could put pence there to make it clear that that's pence. So 478 divided by 20, and I get the answer of 23.9 pence, and that's exactly, it works nicely. Then I get my 15, and so this is 281 divided by 15 equals, or dodgy equals, but there we go, 281 divided by 15, and then on the calculator that gives me 18.73 blah 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 pence. Okay, now because this would normally be enough, and then you'd say the best value is well, which one of those does one tissue cost the least? Well, obviously the 15 box. So I'd say the 15 tissue box, okay, for my best value. On the website, it can't tell whether you've done the right working out, so I've sort of forced you to work out the price per tissue, which is the method I've just gone through, and I've forced you to write it down so I could see whether you've got the right answer. Otherwise, for 4 marks, you could just guess, and the exam won't give you any marks for just guessing on this question. Normally, you even if you get the right answer, you get no marks unless you show the working out how you got it. So the 24 tissue box to 2 decimal places I've asked for, so that was 27.58 because I think the next one was a 3. The 20 tissue box was 23.90 because it was just 0.9. And the 15 tissue box was 18.73 because the next value was a 3. Okay, and that is full marks. Now don't forget, for this one, they won't be as specific. All they'll say is write down the best value. The question will stop at the question mark. None of this, all of this has been added. None of this will be there. So you've got to remember this strategy yourself of getting the price per one tissue, or the amount of tissue per 1 pence, or try and get the boxes to have the same amount of tissues in. Okay, heavy question, but if we've got that right, we're almost at a B. So, question 13, if you'd like to pause the video now and have a go. Okay, so estimating the mean. Now some of my students look at that and go, I reckon it's around 12. Okay, when it says estimate, it means you've got to do work. You've got to work for it. They're not just going to give you 4 marks for just guessing something. And there's a good strategy, a good way of doing this, okay? Now, first thing you've got to do for this type of question is work out the frequency, the fx I call it. Okay, and that is the frequencies times the x's. I call all these x's. Actually, in this question it's t, so I should write ft. Okay, now I'm just going to draw a line down here. I'm going to extend these along. With this question, the x, which I've referred to, doesn't exist really. Now, if you think about it, when you try and do 22 times 0 to 5, well, how do you type that into a calculator? We need a number to represent 0 to 5. And if we picked 5, it would imply that all the values are 5. Well, that's not fair, because that's probably bigger than they actually are. If we did 0, then that would be too low. So Goldilocks theory dictates that we pick number in the middle, the midpoint. MP for midpoint, not Member of Parliament. So we do 2.5 for this one, because it's halfway between them. And if you get one that you're not sure, just get a calculator. So let's do this for the next one. Add the two numbers, the 5 and the 10 together, and then divide by 2. and you'll get the midpoint. Okay, you're finding the mean of the two numbers. Okay, sometimes you get some really weird numbers. These ones are quite nice actually. We can just go through these. There we go, and 22.5. Now the fx is exactly that, we just times them together. So we're just going down, timesing all of these together. Now this is going to take a while, but I'm up for it. 22 times 2.5 is 55. I'm just doing this on the calculator, so I can be absolutely sure. I don't need to do that one on the calculator, because that's times 10, so I can do that one. 12.5 times 14, which is 175. I'm just checking these as we go along. Yeah, that looks fine. 10 times, that's a nice easy one as well. That's 175. And then 11 times 22.5. This one's awkward now. 2,497.5. Now, because that's unusually high, I'm going to check that. I'm going to type it in again. 11 times 22.5. And lo and behold, I made a mistake. Okay, so let's change that. So 247.5. Now I would say that's deliberate that I made that mistake, but actually it wasn't. I must just not press the decimal point hard enough. But always check the weird ones. If you get weird answers, always check them like I did. I was like, well, that's not that much higher, and yet my answer's massive, okay? Right, so what do you do next? Well, what we want to do is we need to work out the sum of the frequencies, which is this one down here, and the sum of the fx's. Never ever work out the sum of the midpoints. The midpoint is just working out. Okay, now I could sit here and add the frequencies up, but it already tells us in the question what it's going to be. 67. Let's do it for fun. 22 plus 10 plus 14 plus 10 plus 11. 67. Okay, so the sum of the f's, and we do this weird sign to say sum of, that just means added up, so when we add up all the frequencies, and we need to work out the sum of the fx's. Okay, now this one's slightly harder because we've got to actually type this in. 55 plus 75 plus 175 plus 175 plus 247.5 equals, and that's 727.5. Okay, now this number is equivalent to all of the numbers added up. This number is how many numbers there were, and the mean, you get this one, this 727.5, and you divide it by this one, 67. Okay, that's how we work out the mean. So let's type that into the calculator. 627.5 divided by 67, and we get a horrible number, but it says round to 2 decimal places, so 10.8. And the next number is a 5 and then an 8, so that's going to be 6, because the 8 will push that 5 up to a 6. So our answer is 10.86. Now, remember I said about checking your answer? Well, the number should be somewhere, looking at these values, somewhere around here, okay? And probably slightly higher, so somewhere around there, because that 22's sort of dragging the mean up a little bit. So you wouldn't expect it to be 12.5, you'd expect it to be closer to 0, so maybe 10 odd. Okay, looking at our answer, it's 10.86. Now if I got an answer of 50, well that's nowhere near these values, that's up here somewhere. You can't possibly have got a mean of 50. The absolute maximum the mean can be is this, and the minimum the mean can be is this. Okay, but it's normally somewhere in between. Okay, so it's a good way of checking your answer. So if you don't get that, then you might want to go back to this question and just check it for working out. Okay, so we're almost at a B. Question 14, if you'd like to pause the video now and have a go. Okay, there is a proper way of doing this question and a sort of quicker way of doing it. If you use a squared plus b squared equals c squared and you're absolutely happy with that, stick with it. Brilliant. That's good mathematics. If you have no idea what I'm talking about with a squared plus b squared equals c squared, I'm going to show you a slightly different method. It's the same thing. Step 1. Okay, these are my 3 steps. Step 1, square, but all the values you've got. Okay, we are using Pythagoras. Okay, this is what I'm hinting at. I probably should have started with that because it's a right angle triangle and there are no marked angles and we have 2 lengths and we're finding a third length. Okay, it has to be a right angle triangle and you have to have 2 of the lengths and you have to be looking for a third length, and that's Pythagoras. So step 1, square the 2 numbers you've got. So 23 squared equals 529. Okay, 44 squared equals, oh, massive, right, 1936. Okay, I should probably write this 23. Oh, that's a bit of working out. Fine. Okay, that's step 1 done. Now step 2 is the only decision you've got to make. Either you're going to add them or subtract them. Okay. Now you might say, well, how do you know whether you to add or subtract them? This length here, the length opposite the right angle, is very special. In fact, it's got a special name, hypotenuse. The reason it's got a special name, and it's like sort of famous, is because it has to be the longest side in a right angle triangle. So the only length not touching the right angle has to be the longest side. Now, if on step 2 we subtracted these, then we by definition get a smaller side. Well, if a hypotenuse has to be the longest side, we want to get as big a number as possible. We need a bigger number than both of these. So step 2, we're going to add. Okay, so let's do this down here. 529 plus 1936. Okay, use my calculator. 529 plus 1936. And I get 2465. And finally, step 3 is square root. Just square root the number that you've got. 2465 square rooted. And on my calculator, square root 2465, and I get the answer 49.6 to 1 decimal place, which is asked for. Now let's just put that on 49.6. The last thing to do, this isn't a step, last thing to do is check your answer. That's 23, that's 44, that's 49.6. This has to be the longest side because it's the one opposite the right angle. So we know we've got it right. So our answer is 49.6. Now, the other method, a squared plus b squared equals c squared, you literally just write it down. Equals c squared. I'm not going to go through it completely. This c has to be the hypotenuse. Okay, that's how this one works. Okay, so you'd call that c. A and b can be one of those two. Put them into the equation and solve it. Try and find out what c is. Okay, I'd say if you don't know that at this point, just do the 3 steps. 3 steps will equally give you the right answer and equally give you all the marks. So if you got that right, and we've got all the ones so far right, you are now at a B. Woohoo! Let's move on. Question 15. Pause the video now and have a go. Okay, now this looks like quite a complicated question, so whenever I have questions like that, I always just try and draw a diagram as much as I can. I haven't really been helpful because I've put 2 place names with similar first letters, so I'm going to say Chell. Let's start at Chell, and then we're going to end at Bolko, so I can call it just B. And then in the middle we have Chem. Okay, So, the distance between Chelton and Chemstow is 22 miles. And I'll just remember M is miles, not meters. Chemstow to Beaucourt. Oh, I need to change that. Oh, let's get rid of that. Beaucourt is 17 miles. Okay, David leaves Chelton at 9 o'clock. He drives from Chelton to Chemstow at an average speed of 44 miles per hour. So 44 miles per hour. What speed does David travel between Chelmsford and Beaucourt to arrive at 9:45? So he leaves there at 9, and he wants to get there at 9:45. So first thing we need to do is work out what time he gets to Chemstow at, and then we have to work out the speed he'll need to do in the last stint. So looking at this, we have a distance and a speed. Now some teachers hate doing this, but I will do it. Oh, click the wrong one. It's this one, is it? Nice little triangle. Okay, the only thing you need to know with the triangle is which one's at the top. Well, speed and time are at the bottom, and distance, which I'll just say dist, is at the top. So whichever one you're looking for, you cover up, and it tells you what the formula is for the other one. We've got a distance and we've got a speed, and we're looking for time. We want to see how long that Chelton to Chemstow takes. So I'm covering up time. It says distance divided by speed. Okay, so I'm going to say Chel to Chem. So we'll do distance, which is 23 miles, divided by speed, which is 44. I'm just going to type that into the calculator. 23 divided by 44, and it gives me a ridiculous... I've been an idiot. It's 22 miles. 22 miles. I was going to say, I thought it was a lot nicer than that. Okay, there we go. 22 divided by 44 is a half. So that is 0.5. Okay, so that would be 30 mins, because half of an hour is 30. Okay, we're getting there. So he gets to Chem at 9:30, because he's going to take 30 minutes. That means he's got 15 minutes. Now 15 minutes in hours is 0.25 hours. And it says here that we do distance divided by time to work out the speed. Okay, so Chem to B to Beaucourt, and we know it's going to have to take him 0.5 and 17 miles. So 17 divided by 0.25, which is quarter of an hour, which is the time he has remaining. So 17 divided by 0.25 is 68. So it would be 68 miles per hour. And hopefully I'll go back and change that. Okay, let's move on. Question 16. If you'd like to pause the video now and have a go. Okay, so one very important word here is the fact they're similar, which means they're enlargements of each other. Now, this one is very commonly answered incorrectly, and I know why. I completely understand why. So, some of you have looked at this and gone, well, if they're similar, we can work out a scale factor. Fine. The scale factor between B and A, I'm working this way, is going to be, well, 12 times 2 is 24. So the scale factor is 2. Okay, that means that this one here is twice as big as this one here. So the temptation is you times this by 2. It doesn't work like that. Okay, the linear scale factor is 2, but a line, linear, is one-dimensional. The area scale factor is not going to be 2. It's going to be 2 for each dimension, which is obviously 4. The volume scale factor is not going to be 2. It's going to be 2 for every dimension. So there's 2 times 2 times 2. So the volume scale factor is going to be 8, and the area scale factor is going to be 4. So it's not going to be 70 times 2, it's going to be 70 times 2 cubed, or 8. 7 times 8 is 56, and add a 0. So it's going to be 560. Okay, now that is confusing for people to comprehend, but if you think about, I'm really bad at drawing this, but if you think about a cube, okay, and that cube is 1 by 1 by 1. Now if you imagine I just double that, so I make it 2 across, okay, but make it similar, so make it exactly the same as before. It would mean that it would have to be 2 up. Well, the area of that front face was 1, and now the area is 4. And it has to be 2 across as well, like 2 depth-wise. Okay, so the volume is going to be 2 times 2 times 2, so the volume is going to be 8. So we've doubled the length, but the area has times by 4, and the volume have times by 8. Okay, so hopefully you can see that 8 of these little cubes fit into this slightly bigger one, into this one that we doubled the length. Okay, so there's 8 of these little ones that fit into this bigger one. And it's the same with this. If you imagine, if I do it all the way around like that, okay, and let's show you that you can fit B in this 8 times. Okay, so if you look at that B there, you can fit 4 of those at the bottom of A and 4 of those at the top of A. Okay, so it's going to be 8 times the volume. Right, I've gone a little bit too far over that, but I'm sure there'll be a question on it, which is why I've sort of done that. Now this time we're working the other way, and this is common for a question B, is to go the other way with this. So we're working from A to B. Now normally we'd divide it by 2, but we're talking about surface area here. So it's going to be 640 divided by 4, which is the area scale factor. Okay, I might as well do this in the calculator. Okay, so 640 divided by 4 is 160. So it's 160. Let's check that. So it's 160, we're going to times it by 4, and we get 640, so that works. Okay, spend a little bit longer on that question, but I think it was worth going through, and I got a lot of questions the first time I went through this question, so hopefully I've answered those. So, question 17, if you'd like to pause the video now and have a go. Okay, now this one is sort of on compound interest, but it's not as complicated as that in a way, and it makes it more complicated. You get a different percentage each year. So instead of with compound interest you'd normally be able to use indices, we're not going to be able to in here because they're different amounts. First thing to realise is what a multiplier is. A multiplier is a way of working out 4% of something and then adding it onto the original amount in one go. With all percentages, you start off with 100%. So our initial investment is 2,000, so that's 100%. On the first year, we're adding 4%. So in total, at the end of that first year, we're going to have 104% of our original amount. As a multiplier, we divide it by 100 and it's 1.04. Okay. Same thing with the second time. So at the start of the second year, we start off with equivalent of 100% of what he has. We're adding on 2.2% this time. And so that means we're going to have 102.2%. And as a multiplier, that's going to be 1.022. You just divide it by 100. And these multipliers are brilliant because all we do now is we do 2,000 and times it by the multiplier for the first year. Remember, it does all the hard work for us. That one there will add on the 2,000 for us. And then times it by the multiplier for the second year. And it's that easy. So I get my calculator, 2,000 times 1.04 times 1.022. And I get the answer of 2125.76, which works nicely. So it's £2,125 and 76 pence. And that's it. That's all we have to do. How easy is that? Now, if you had it at 4% for 10 years, okay, all you would do is you do times it by 1.04 to the power of 10. You're effectively doing that 10 times. Don't ever fall for the trick of just timesing it by 10. Okay, that would work for simple interest sometimes, but not for compound interest. Okay, because the amount you have in your bank at the end of the first year will then be used for interest for the second year. Okay, so your bank account will grow and grow and grow quicker and quicker the more money you have in it. Okay, question 18. If you'd like to pause the video now and have a go. Okay, so with this question, stratified sampling, this is when you have a big population and you want to pick a smaller population, or sample we call it, and you want that sample to be representative of the whole. So if you imagine you've got a school with mainly year 11s, but there are a few year 7, year 8, year 9, year 10, but it's mainly year 11, it's a big year 11 school, then if there was a questionnaire, you'd be quite annoyed if all the year groups had the same amount of say. You'd want more year 11s asked because there's more of you. And that's what stratified sampling is. It's trying to make sure that a fair amount of people are asked from each group. Now in this one it's about male and female and choice of ride at a theme park. So it's looking for how many females who went on the log flume we're going to ask. So there are 3 numbers you need for this. You need the total amount, which actually is quite nice, it gives us in the question. Okay, in fact I might use my highlighter for this, so 128. We need the amount of females who went on the log flume, which is 20. And we need the amount in the sample, 40. First thing you do is you work out the fraction that makes of the whole. So 20 over 128. So we've got a fraction there, and we then times it by the sample to see how much of my sample are going to be females who went on the log flume. And that's it. So 20.128 times 40, and I get 6.25. So all we need to do is get 6 of them, and then we need to saw one of them into a quarter. Maybe not. Okay. What you need to do also is to round your answer to the nearest integer. It won't ever tell you that, but you do need to, because obviously you're saying, I'm going to ask 6 people. I'm not going to ask 6.25 people, clearly. Now, what they used to have is questions that you had to check that the 6 was accurate. What you used to have to do is go through each of these 6 and work them out, and then see if it added up to 40. They've actually got they've got a lot more lenient on that and allowed you 6 regardless of whether it makes sense. But I would recommend, if you've got time, work out the other ones and check, because sometimes you might have to round this up just to make sure that you add up to 40. Sometimes it adds up to 39 and you've got to pick the one that's closest to rounding up and just round it up anyway. But actually they're pretty lenient on this. So I might not be worth the time, especially for 2 marks. Okay, let's move on. Question 19, if you'd like to pause the video now and have a go. Okay, this question here, we're going to be talking about multipliers again, but a different use of them. This is called reverse percentages because we know what the value is now and we're working backwards to find out what it was. So I'm going to do the same as I did before with the previous question. I'm going to start off with 100%, and this is for 2014. Okay, so I've probably run out of room there, so I'm just going to 2014. And I'm going to have 2015. Now, in 2014, the sales went down by 15%, so minus 15%. So that means in 2015, we had 85% of the sales that we had in 2014. 85%. As a multiplier, that is 0.85. Now, if we were working from here to here, multipliers are times. But it's given us the sales in 2015, 7751. And so we're working backwards here. So instead of this being a multiplier, it's a divider. Well, actually, we still call it a multiplier, but you're dividing it. So you're doing, on your calculator, 7751 divided by 0.85. And when I have that up, it is 775.15. So it's 7750.15, and that's it. I would recommend, if you're having problems with percentages, try and use multipliers, try and learn them before the exam. If you've got a method, and there's loads of methods of doing this, you work out 1% and work from there. If you're happy with it, stick with it. This is just one way. Okay, this here now is asking about percentage increase. Okay, so to work out a percentage increase or decrease, it is change, which is not coming out at all, change over original times 100. So it's the amount of change over the original amount times 100. Okay, so how much has it changed? Well, let's have a look at the figures. So in 2015, it was 7751. It's now 12021. So 12021, take away 7751. It's changed by 4,270. That's how much it's changed by. The original is in 2015. So the original is 7751. And then obviously times by 100 to make it a percentage. So 4270 divided by 7751 times 100. And I get, and it says to the nearest percent, so I get 55.0896, so it's 55% to the nearest percent. 55. Let's check that makes sense. So 55 is just over 50%, which would be a half. And so half of that would be roughly maybe 300 odd, 400. Add that on, well, that seems to make sense. Seems to be roughly right. And it is correct. Fantastic. So if you've got this correct, you are currently at an A grade. Woohoo! Let's move on and see if we can get even higher. Question 20. If you'd like to pause the video now and have a go. Okay, so this looks, I don't know, maybe you're looking at this going, this looks easy or this looks really hard. This is actually quite a tricky question. So, I'm going to draw some lines, but I don't think it's going to be big enough, but I'm going to do it anyway. So I'm going to draw some lines down, because I like doing that, it just makes it look a lot neater. These lines are dodgy. Okay. Now there are going to be quite a few steps to this, so you've got to be patient with this question. The first thing I tell anyone when they're doing this type of question is put brackets around the top and bottom. The second thing I tell them is whenever you're rearranging a formula or whatever, try and break free of fractions and brackets. Okay, I know I've just put brackets in, but try and break free of them. So the first thing to do is get rid of this fraction. I can't access anything at the top or anything at the bottom with this fraction here. So the first thing I'm going to do is I'm going to times by the denominator to get rid of the fraction. So I'm going to times both sides by y minus 3. So I've already got an x there. So on this side I'm going to have that x and I'm going to have the y minus 3. On this side I've times by the denominator, so it just gets rid of the denominator. So 6 minus 5y. And because they're the only thing on that side, don't need the brackets on those. So I'm going to open these brackets now, because that's my rule. Get rid of fractions and brackets. And I do what's called smars and rainbows to break them free of them, to expand them. X times y is xy. Minus 3 times x is 3x. So that's minus 3 times x, which is minus 3x. And this one I haven't done anything with yet. Now, what I want to do is get all of the y's on the same side. So currently there's a minus 3x, which I want to get rid of, but I want this minus 5y on this side. So I'm going to add 3x to both sides. Okay, to get rid of this minus 3x. So that's xy equals 6 minus 5y plus 3x. But I want the y on that side, I want that 5y on this side. So I'm going to add 5y. So I get, and I'm going to do it down here, xy plus 5y equals 6 plus 3x. Now a lot of people will stop here and go, well, how am I going to get one lot of y? I don't know any way of putting these together to get a y. Well, actually you have been doing a strategy to make one of something when there's currently two. And that strategy is called factorizing. We're going to factorize this. We're going to divide out the y from both of those. So xy divided by y is x. 5y divided by y is just 5. And then we haven't done anything to this side. Then I'm going to divide by this bracket. So we could divide by the x plus 5. and divide by the x plus 5 there. And my pen really doesn't like the bottom of the screen, so you're going to have to bear with me. So we're going to end up, and I'm going to might as well just do it in here. So we've just got a y on the left hand side, and at the top of this fraction we've got 6 plus 3x, but we're dividing by x plus 5, so that x plus 5 at the bottom. And that's it. That's a perfect answer. You might want to write 3x plus 6 to put the x's first, but you won't lose any marks if you have the number first. And that's it. Finished. Finito. Woohoo. So we're halfway. Well, we're quite a far way into an A grade at the moment. So let's keep going. Question 21. If you'd like to pause the video now, have a go. Okay, so this is quite a weird question because you've got a right angle here, and how do we know it's a right angle? Well, it says that it's a rectangle, so it has to be a right angle here. Then you've got a weird triangle through here, okay? You've got to expect that when you do Pythagoras and trigonometry, that you will probably get a weird looking shape. They don't normally do just a right angle triangle anymore, although we had one earlier for the Pythagoras question. So, which one is this, Pythagoras or trigonometry? Now, someone in the comments when I did this a previous video was adamant you could use Pythagoras straight away. You can only use Pythagoras if you know two of the sides. Well, do you know two of the sides? Not really, because this doesn't say it's a square, it says it's a rectangle. So we don't really know what this side is. It might be 19, but it might not be. So you only know one length, which is this one. And you can't do Pythagoras if you only know one length. So that only leaves trigonometry and SOHCAHTOA. So, what do we need to work out? Well, it's saying work out length CE, which is this long one here. There's no way we can get that straight away. What we might want to do is work out this one here, CB. And then when we've got CB, then we've got an angle here, okay, which we can work out because that's 90 degrees, so just take away from 90, and then we've got a length and an angle, and we can just use trigonometry to finish it off. This is not the only way, but I think this is the easiest. So we're going to work out, I'm going to call this little a, okay, this length here is CB. I'm going to call it little a for now, it could be called anything, just for simplicity. So, first of all, we've got to label the sides for trigonometry. Well, this is the opposite, because it's opposite the marked angle, and this is the hypotenuse, because it's opposite the right angle. Okay, so looking at SOHCAHTOA, it is going to be a SOH. So sine, you always sine the angle, 63, equals O, which is 19, over h, which I've called little a. Now when you're in this situation where you've got an unknown at the bottom, just swap them over with the sine 63. How easy is that, eh? So if the unknown is at the bottom, swap them over. Effectively we're timesing both sides by a and then dividing both sides by sine 63. Okay, so let's type that into my calculator. 19 divided by sine 63. Now if you're following along with me and you've pressed the fraction button or you've tried to do that and it's come up with an error, it's because you haven't closed the bracket. Whenever you click sine, cos or tan, it opens a bracket. When you've got it as a fraction or whatever, you need to close that bracket. Now the answer is 21.32419.852, etc. Now, two things. If you type that in and you didn't get 21.3 something, The reason is your calculator is set to radians. It's got a little R in it. You'll need to set it to degrees. Now, I can't go through the instructions because every calculator is different. Normally, sometimes if you press mode or shift and then mode, you can change it, or just look it up online, or ask a teacher, ask a friend, ask someone who's done the exam before. Okay. Right, so we've got this. Now, second question you might ask is, why have I written it down to a ridiculous amount of accuracy? Well, it's because I'm going to be using it for the second part of the question. Okay, so I don't want to have a rounding error in my final answer. So I'm putting down a ridiculous amount so that it keeps it accurate. Okay, I'm going to do work out this angle now. This angle here is just 90, so 90 take away 63, which is 27. Now, I'm going to forget about the h there, because that's not going to be h anymore. And I'm looking at this triangle here. If I get my highlighter, then I can show you it's this one here that I'm looking at next. Okay, this is the right angle I'm now doing. So on this right angle, this is actually the adjacent. Okay, and I'm trying to find this length here, which I'm going to call little b. And this length here is now the hypotenuse. So we've got A and H, so SOHCAHTOA means that we're going to use cos for this bit, and I'm going to do it up here. So it's going to be cos 27 equals A, which is the 21 point whatever it is, okay, over H, which is little b. Do my trick again, switch these around. So little b equals 21.3 blah 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 over cos 27. Okay, type that into my calculator. Now you might want to just type in 19 divided by sine 63 again, so you get that number back. Okay, and this time I'm going to say divided by cos 27, close bracket, and that is 23.932 blah blah blah. I wanted to one decimal place, so that answer is going to be 23.9. Now let's double check that it all makes sense. Looking at that, that's fine. Is that a realistic number? Well, what number does it have to be greater than? Well, it has to be greater than 19, because I know CD is 19. Well, 23.9 is greater than it. And let's just check, calculate the length of CE, which is the one we've looked for. Okay, sometimes it might ask for DE, which then you'd need to subtract 19 to work out that. Excellent. Okay, so that's another question finished, which is great. And there are other ways of doing that question. That is not the only way. One other way is you could work out this angle, and then you could work out this angle, because this would be 63 degrees as well, and then you take it away from 90, and this would be 27, and then you could just work out this one, then add on the 19. Okay, it doesn't matter which way around you do it. I think the way I went through it is a lot easier maybe to spot for everyone. Okay, let's move on. Question 22. If you'd like to pause the video now, have a go. Okay, so quadratic formula. The reason we know that it's a quadratic formula and not factorising is give your answer correct to 2 decimal places is a bit of a giveaway that it's going to be quite complicated. First thing you need for the quadratic formula is to know what A is, which is the number before the x squared. It doesn't include the x squared. You then need to know what B is. B is the number before the x, so it's 7. And C, as most of you would write down, is 2. Well, most of you wouldn't write that down because you know that it's the number at the end, but it's a negative 2. Okay, remember that minus belongs to that 2. So you've got A, B, C. Next thing you need to realise is what the quadratic formula is. Well, they still give it to you. You're one of the last years they will give it to you. So make sure you use it. X is minus B plus minus the square root of B squared minus 4AC over 2A. And this is just an exercise in substitution. We do it twice because this plus minus means you do it once with a plus and once with a minus. So minus 7 plus minus square root of 7 squared minus 4 times 2 times minus 2 will be a plus 4 times 2 times 2 over 2 times 2. Then we do it again, so that's 1x. Then we do it again to work out the other solution, minus 7, and I've said plus minus there. Let's call that a plus, and then a minus. I've sort of gone in autopilot mode. 7 squared plus 4 times 2 times 2 over 2 times 2. Now you might say, well hang on, why have you put a plus there and it was a minus? Well, I've just sorted out the signs. That's a minus 2 there, so the minus and the minus will make a plus. Okay, what you might want to do instead of doing that is minus 4 on your calculator, minus 4 times 2 times bracket minus 2, close bracket, and that might be easier because then you can just go in autopilot and switch your brain off, which I wouldn't recommend you do in your maths exam, but there we go. So I'm just going to type it into the calculator. Now I'm going to press the fraction button because it makes it a lot easier, and I'm going to click minus, which is the minus button, 7 plus square root 7 squared. I'm going to do the top left method, the top right method. So take away 4 times 2 times bracket minus 2 close bracket, and then I'm going to press the down cursor key, 2 times 2. I'm just going to press equals, and it comes up as a third, but I'm going to press S to D to get it as a decimal because that's what it's asking for, and it says 0.2. Now to 2 decimal places it's 6.5, so that 6 will turn to a 7. Now I'm not going to press clear. What I'm going to do is use the cursor on my calculator to scroll across to where it says plus. I'm going to delete that with the delete button and just click minus. How easy is that? You get the second solution straight away, and you don't have to rewrite the whole thing. How great is that? We didn't have that in my day. And it was only like 15 years ago I took this exam. My goodness. Right, so where is it? 7, 6, 5, so it'd be 7, 7. Let's just check that's right. Yep, that looks right. And those are our solutions. So 0.27 and minus 3.77. Fantastic. Let's move on. Question 23. Pause the video now and have a go. Okay, so I'm going to do a diagram I did earlier because I think it helps with this one. And draw a line. I like lines. And it says write down the lower bound of x. Okay, so x is 4.5 rounded to nearest 1 decimal place. So it's 4.5. It could have been 4.4, or it could have been 4.6. Those are the next ones along. Okay, but it could have been all the way up to here before it rounded to 4.6, and it could have been all the way down to here before it rounded to 4.4. Well, again, this is like the try and improvement question. Where's the cutoff point before it actually rounds to 44? The cutoff point is 44. Well, sorry, 4.4. Oh, it's been long. Right, 4.4 5. If it was 4.44, it would round to 4.4. But anything greater or equal to 4.45 would round to 4.5. Okay, so the lower bound, the lowest that value could be, is 4.45. Okay, and that's the lowest it can be. There is a way of doing it. If you look at that one decimal place as 0.1, halve it and then take it away, but I find that drawing a diagram is so much easier. Okay, now this one's slightly harder. Find the upper bound of t. Okay, so to find the upper bound, we need this number here to be the maximum that it could be. Okay, because we're adding to it. But the bigger this is, the smaller this fraction becomes. Okay, so we need this number to be the lowest, or the minimum. Okay, the minimum it can be. So we need the lower bound of y and the upper bound of x. The lower bound of y is quite straightforward. Okay, the lower bound of y is going to be 3.55, using the same thing as we did before. Now, this is where it gets a bit contentious. Now, in the last video when I did this, there were quite a few comments saying that I got this wrong. You are so tempted here to write 4.549999999999. Okay, that is a correct answer. Okay, 4.549 recurring is correct, but my answer is this. Now, I know that will round to 4.6, but 4.55 is the same as 4.549 recurring. Just a little side thought. 1/3 is 0.3 recurring. 2/3 is therefore 0.6 recurring. Okay, let's just tidy this up. So therefore 3/3, following the same pattern, is 0.9 recurring. But 3/3, 3 over 3, is 1. Therefore 0.9 recurring is the same as 1, mathematically identical. You might say, oh, it's slightly less than 1. No, it's not. It's equal to 1. I think until you do calculus, you don't quite understand why. You don't need to understand why. All you need to understand is that is an absolute correct answer for an upper bound. Okay? So it is absolutely justified saying 4.55, and it makes the question so much easier to calculate. Okay? So 4.55 plus, and then press the fraction button, 1 over 3.55. And that's absolutely fine. You can absolutely write that down. And so the upper bound for t is 4.83 to 2 decimal places. Let's tidy that 8 up. Now if you did 4.549 recurring plus 1 over 3.55, you would get the same answer anyway. Okay, but you would be absolutely fine doing it either way. I find putting it to a 4.55 so much easier. Okay, and always correct on the mark scheme, because mathematically it's the same thing. Right, question 24, and I'm going to put both of them up. So if you'd like to pause the video now and have a go. Okay, so histogram question. Dreaded histogram, or maybe not. I like histograms. Histograms are the same as bar charts, apart from quite a few things. First of all, this scale here is continuous. Secondly, the widths can be different sizes. Thirdly, the frequency is not the height. The frequency is the area. Okay? So the area, the bigger the area, the bigger the frequency. It doesn't matter whether it's higher. Okay? So therefore maybe this one, although it's higher, has less frequency than this one, because if you look at the areas, the amount of squares inside it is less. Okay. Now there is a formula. There is a triangle. Maybe some teachers will hate me showing you the triangle, because some teachers are purists, they hate triangles, but I'm going to show you anyway, because it's helped some students, and my goal is to help as many students as I can, whatever their ability. So, in the triangle, frequency is at the top, class width, which sounds posh, is at the bottom, and frequency density is also at the bottom. Okay, it's like speed, distance, time triangle, and the triangles we used for other things. So, class width sounds posh. It's not that posh. It's just the width of the bar here. Okay, it's the distance between 0 and 10 would be the class width. Frequency density, it's just made up. It's just something to call this axis here. Okay. Now, this triangle is slightly misleading. One question you might ask is, why have they put the first value in? Well, let's work it out. Class width is 10. Okay, so I'm going to put the 10 there. The frequency density is 0.5. And 10 times 0.5 is 5. So why have they put that in? It's because that is slightly misleading, that triangle. Frequency is proportional to the class width times the frequency density. So it could be that they've written 10 there. Well, you've just got to remember that when you times them together, you've then got to times it by 2. Okay, they very rarely ask ones that it's not just a one-to-one relationship, but sometimes they would give you an example of one and it won't be 5, it will be 10. So always check that first one to see whether it works, and this time it does. So the next one's quite easy. It's 10 times, and let's look at the height, 0.2. Which is going to be 2. This time it's 5, remember unequal class width, slightly thinner, times 0.6, okay, which is going to be 3. And do this on your calculator, feel free. 10 times, 0.8, which is going to be 8, and it is 15 times and 1. Well, there we go. It's always an easy one. Okay, and that's perfect. That's absolutely fine. Okay, work out the proportion of businesses of a turnover greater than 40,000. Okay, so we're looking for the proportion of businesses that have a turnover greater than 40,000. So let's have my highlighter on. This is quite thick, but actually let's just do a black line up from here. So we're looking for the proportion that are, I should probably switch it off now, that are greater than that point there. Okay. So what fraction of that last bar is this? What fraction of that last bar is this bit here? Okay. Well, it's 2/3 of that last bar. Okay. That whole bar is 15. 2/3 of it would therefore be 10. If you think of these rows, each equaling 5, 10, say columns, 5, 10, 15, that works. And we're shading 2 of them, so it's 10. So it's 10. And it says proportion, so we want it over the whole amount. So let's get a calculator out and work out how many there are in total. 5 plus 2 plus 3 plus 8 plus 15. And it's 33. So 10 over 33. So 10 divided by 33, which is 0.30. So it's 2 decimal places, it's 0.30. And because it's 2 decimal places, we put the O, okay, even though it's 0.3. Okay, find an estimate for the median turnover. Now, we like the median. Okay, the median is quite tricky. But to find the median, what you can do is do a running total. Oh, wow, that was the wrong one. That one there. You can do a running total, okay, and that's what I'm going to do with this table. Okay, now the median is the halfway point. Okay, so we worked out there were 33. So I'm going to do 33 divided by 2. So that gives us 16.5. It's horrible. Why have I made it 16.5? Let's just check. Let's check I've added these up right. Yeah, I have. Okay, so the first 5 are in this one. Then, so this is a running total I'm doing. Then the next 2 are in that one, so that gives us 7 so far. The next 3 are in this one, so that's 10 so far. And the next 8 are in this one. Okay, so we know the median will be in this one. Okay, this 4th column. Alright, and there is the 16.5th value. I wish I'd written this question better. So, it's going to be somewhere in here. Now, what I could do is I could just count the squares, work out how many squares there are in total, and then just find a point where there's the same amount of squares on the left and the right. Okay, that would be absolutely fine. What I'm going to try and do is a more mathematical approach. The 10th value is up until this line, and the 18th value is up until that line. So we're looking for the 16.5th value. Okay, so we're looking for the 16.5th value. Okay, so we know the 10th one is up until this point. We know the 18th one's up until this point. So we want to work out the fraction of the total way across that we've got to go. To do that, well, it's 6.5 over 8. Okay, because it's 6.5 across is into our median, and then there's 8 across in total. And that is 13 over 16. And we times that by the width of the bar, so 25 to 35, so that's 10, so I times that by 10, and then add it on to the lowest point, so add it on to the 25, which gives me an answer of 33.125, which I'm going to put as 3. Okay, so let's try and get some working out for that. So the fraction that the median is on that bar is 6.5 over 8, okay, which is the same as 13 over 16. And that bar starts at 25 and ends at 35. Okay, so its class width is 10. So I want to times that by 10. Okay, which is, what did I say it was? 13 divided by 14. 13 divided by 16. Doing well. Can't even read my own handwriting. So 13 divided by 16 times 10, which is 8.125. But that didn't start at 0, it started at 25. So we add that on to 25. And that gives us the 33.15. So we do 8.125 plus the 25, which gives us 33.125, which rounded is 3. So it's nice easy question. I doubt they'll have a median which is 0.5, and in fact yeah, anyway, let's move on from that. Okay, so question 25, if you'd like to pause the video now and have a go. Okay, so we're looking for length BC, but the problem with this is we've only got a length on that. Well, actually we've got slightly more than that. We can work out what this one is. If you do 180 take away 70, that's going to be 110 degrees. So we've got two things on this, but we don't have this angle here. We don't have this angle here. We obviously don't have the length we're looking for, but we don't have this length here. And there's no way you can do a non-right angle triangle with just an angle and a length. Okay, so we need something else. Are we ever going to find this angle here? Well, no, because we could work out this angle by taking these away from 180, but there's no way of working out this angle here. Are we ever going to work out this angle? Well, I don't really see a way of getting this angle. Okay, so the only thing left is this length here. So we're looking at this triangle here now, and we're looking just at this length. Right, how are we going to work this out? Now, I'm going to look at this and go, well, we've got two lengths, we've got two angles, and each length is opposite the other angle. So this is screaming sine rule to me, okay? And this is sine rule. Sine rule is where you have any triangle, it's not a right angle triangle, it's any triangle, where you've got a pair of lengths and angles opposite, a length and angle opposite each other, and another length and angle opposite each other, one of which you're looking for. Okay, now with the sine rule, we label these, little a, I'm going to call this, big A, which is already labelled as, big B, and little b. Okay, little things are lengths, big capitals are angles. Okay, and the sine rule says little a over sine big A, which is 29, equals little b, which is 5.7, over sine big B, which is 70. Okay, or with the sine rule, it doesn't matter which way around these are, as long as they're the same. If you put sines at the top, that's fine, as long as they're both at the top. The reason I've put the length at the top is because that's the one we're trying to find out, and it's a lot easier having the unknown at the top. Okay, so therefore A is 5.7 over sine 70, and we're going to times both sides by sine 29, so we can just type it all in at once. So on my calculator, fraction button, 5.7 over sine 70, remembering to close the bracket, and then I'm going to go out of the fraction with the cursor button and press times sine, 29, close bracket. It churns away and it gives me 2.9407644. Now, like I explained earlier, the reason I put loads of digits down is because I know I'll need this to use this on the next one. Okay, so we've got this, we know what A is, we know what this length is, and we've got a middle angle, and we're trying to find the third length. Now with a triangle, if we have three lengths and one angle, and we're trying to find one of the lengths, you're probably going to be using the cosine rule. And the cosine rule is as follows: a squared equals, and I'm going to have enough room up here, I think I am, equals b squared plus c squared and minus 2bc cos A. Okay, so the unknown A has to be opposite the angle that you know. Okay, or you have to have a pair of them opposite each other. Now, because this is the one that's opposite the unknown, which I'm confusingly going to call little a, again, I'm going to call this big A, this angle big A. These other two, it doesn't matter what I call them B and C, but it doesn't matter. So this little a is now going to be called as C. This is where things get confusing with this. Okay, so I'm going to use a bit more space on this. So a squared equals b, which I've called 7 squared, plus c, which is, I'm going to just put 2.9 ... squared, minus 2 times 7 times 2.9 ... times cos A, which is 110. Okay, and if A squared equals that, then to work out what A is, I'm going to square root it. So I'm going to probably, for the simplicity, get rid of that squared and just put a root over the whole lot, so that I can just type it all in at once. Okay, so I'm going to type that into my calculator. Square root and 7 squared plus 2.94076464 squared, take away 2 times 7 times 2.94076464 times cos 110, close bracket, equals. And the calculator went away for a second, but it came back with an answer, and that answer is 8.4, and it says 69, so it's going to be 7 to 2 decimal places. So it's going to be 8.47. Let's check if that makes sense. Looking at the numbers, 5.7, 7 there. Yeah, that sounds reasonable. It sounds reasonable that that would be slightly longer than this one with a 70-degree angle there, maybe. Yeah, I'm quite happy with that. Okay, right, let's move on. So, question 26, if you'd like to pause the video now and have a go. Okay, so question 26. Let's have a look at this. So it's frustum, and it's got a cone, and the height of the small cone, height of the large cone, and it looks like a standard frustum question. So with a frustum, which is the bottom bit of a cone, what you've got to do is work out the whole volume of the cone, volume of the whole cone, work out the volume of the small cone on top, and then take them away. Okay, so we're going to work out, and I've not got an awful lot of room here, but we're going to work out the big cone first. Big cone is 210 tall, and it is 40 wide. Okay, the the volume of a cone is, from memory, 1/3. What is it? Times pi r squared h, isn't it? Would it be, yeah, pi r squared h. So that's 1/3 times pi times, now what's the radius? Well, the radius, the diameter is 40, the total distance across is 40, so the radius is going to be half of that, which is 20. 20 squared, and then the h is the height, 210. Okay. Type that into my calculator. So I'm going to type pi times 20 squared times 210 equals, then divide by 3. And it says it in terms of pi, but I'm going to press S to D. In fact, no, let's do it in terms of pi, a lot easier. Okay, you could write it not in terms of pi, but actually it helps me, it's probably a lot quicker later on if I do it in terms of pi. Okay, it helps me keep it accurate, which is good. Right, we're going to do the small cone, which is 105. Okay, and now this is where we get into problems. Does anyone do you notice what problem we have? Hopefully you do. Problem we have is we don't know the diameter of this bit here. Okay, we know the diameter of this one because it tells us. Well, these two cones are mathematically similar. Okay, this one here is, or this big one is an enlargement of this small one. And if you look at the scale factor, the big one is 210, the small one is 205. Therefore, the scale factors are half to get to the smaller one. So if that's 40, that's going to be 20 centimeters. Okay, so that's 20. So the radius is 10. So the volume is 1/3 times pi. We've got the formula already. Times 10 squared times 105. Okay, let's type that in. So pi times 100 times 105. And this time we have 10500 pi. And then to work out the volume of this, we just take them away. So it's, I'm going to write it down here, 28000 pi, take away 10500 pi. Okay, so 28000 take away, see that's the wrong way around, yeah, 10500, which is this, 17,500. But it doesn't want it in terms of pi, it wants an actual value, so let's just times that by pi. And we get a horrible number. So 2 decimal places, so I'll write it up here, 172,718.01. 0.08. Helps if I can read. Okay, so what's it? 172,718.08. Okay, it's 0.077, but we round it. Excellent. Happy with that? Let's move on. So, question 27. If we can get to there. So, if you'd like to pause the video now and have a go. Okay, so probability was sort of on the first paper as part of a tree diagram, but there might be a probability question that's not part of a tree diagram. So in place game twice, they can be picked for both games. So they could ask independent question, which this is, or they could go for a question where the probabilities change after each event. Okay, so that's the choices they can go to. A conditional, there we are, couldn't remember the word, conditional probability, which is where the probabilities change depending on what the first one was. Okay, so there are 19 students, 5 boys, 14 girls. What's the probability that 2 chosen students will be of different genders? First thing to realise is how that can happen. Well, it can be boy and girl, or it could be girl and boy. So probability of boy is picked first of all is 5/19. Probability of girl is then picked is 14/19 because they can be picked for both. Okay, if they couldn't, then it would be over 18. And then girl is picked is 14/19. And then a boy is picked, that's 5/19. The word and in probability means times. The word or in probability means add. So I'm just going to pick up my calculator and just type that in. So 5/19 times 14/19. And then you'll notice that I can just double it. Okay. and I get, if as a fraction, 140 over 361. Okay, let's check that makes sense. Times 14, 70. And then times by 2, yeah. Seems to make sense to me. Excellent. And that's it. 3 marks. Easy. Right. On an A star. Let's just see if we can finish this off. Last question. Pause the video now and have a go. Okay, so when maybe C and B grade students look at this and they've got some time left of the exam and they want to give it a go, even though they may not have understood this in the lesson, they look at things that they can divide top and bottom by, which is great because in lower questions, that's what you're going to be looking for. With this question, there is nothing that you can divide all these by. The x squared there is literally an x times an x. That's all it's got that you can divide by. And this minus 9, well, you can divide by 9, 3, 1, but that hasn't got anything in common with that. So it's a non-starter straight away. What they're looking for you to do here is to factorise both top and bottom. Okay, you'll either get one bracket or two brackets. I can tell you now, one of the brackets at the top and one of the brackets at the bottom will be the same. You'll cross them out and then you'll write down the remaining brackets in your answer. Let's see if that works. Well, this top one is called the difference of two squareds. Okay, so we know the two brackets are going to be x plus 3 and x minus 3. Okay, because when they expand, they make x squared plus minus 9. Okay, if you don't know what I'm talking about there, just look up in your revision guide, textbook, whatever, difference of two squareds. This bottom one, now let's put down what we know and then we can cheat a little bit. Okay, so we know that one of them has to be 2x and one of them has to be x. Okay, we know that they are both negative, otherwise you won't get the positive there and the negative there. So they both have to be negative. Okay, and looking at the top and bottom, well, the only one at the top that's negative is this one. So this sort of has to be 3, otherwise we won't be able to cross them off and simplify it. This is 24, and 3 times 8 is 24, so that's going to be an 8. Let's check that works. 2 times 3 is minus 6, because minus 3, minus 6, minus 8 times x is minus 8. Minus 6 take away 8 is minus 14. And minus 8 times minus 3 is positive 24. Then simply we cross off bottom, cross off top, and we're left with this. Done. How good is that? X plus 3 at the top, and 2x minus 8 at the bottom. Hurrah! We have finished the exam walkthrough for the Edexcel prediction. Don't forget, all of this stuff is online. If you try and access any of the resources that we have online and it doesn't work, check the description. If the website is down, I do have now, thankfully, after a week of sorting it out, I do have a backup site. As I said at the start of the video, the backup site is incredibly expensive. So if you can use the onmaths.com website, that would be much appreciated. But if it does go down, please do feel free to use that backup site. The backup site, you can't log in, there's no forum or anything else, it's just the questions. So if you're panicking that you can't access it, which I know a few of you couldn't with the paper ones the night before the exam, then feel free to do so. This is not it for the higher GCSE Edexcel paper. I am going to keep doing demon questions. Now, on the paper 1 demon questions, a lot of you noticed that a lot of them were almost identical to the ones that we had done in the demon question and the alternative paper. So clearly my demon questions are what Edexcel are looking for. However, I think that this paper 2 will be a lot more accurate given how predictable Edexcel generally are on their paper 2s, and there's a lot of topics which I've gone through in this paper that they love putting up. If you enjoyed this video, please click like. If you really enjoyed it, please click subscribe. Keep your eye on the On Maths website and the YouTube channel, because I will be, as I said, doing a heck of a lot more stuff to try and help you guys with paper 2. If you've got any comments or you want to contact me, please leave them in the comment section, or go to the website and join the website and talk to me on the forum. I look at the forum a lot more than anything else. If you want to talk to me as well, I'm on Twitter. Anything I put up, I will put on Twitter. I'll put straight on the site. I'll announce it so you know when and where to go for extra help. If you have any ideas of stuff you want me to cover before paper 2, please let me know. All of the topic busters on the website all of them are suggestions from people asking me to go through certain topics, and that's where those have come from. And the demon questions as well. Most of those have come from you guys asking me. So if you have anything else you want me to go through, please let me know. All the best of luck for paper 2. Thank you very much for listening.